Welcome back. All right, we're starting week 2, Algebra 1. Now, on the handout that I really doubt any of y'all are watching, and very few people are watching the videos, because on the first day of school, everybody wanted to get to the homework done. That might be okay with some of this stuff, especially at the beginning, but it's going to get harder faster, I promise. And you may not be able to jump right into things. All right, on these warm-ups, I'm not going to do them because those are for you. All right. If you want to me to go over some for you, I will in a WebEx session, but we're just going to keep on cruising. We'll go through today's stuff. All right. This is equations with variables on each side. All right. We still have our same steps. Now, I think this is kind of funny. Show your work. Unless you're, I don't know how many of y'all are actually using pencil and paper or using the handouts. Some people may have like this little XP pen thing like I'm using to annotate. I know some people can get the PDFs and use Kami if you want to, but we can't really do this now. But if we were in a regular class, sans pandemic, we could. All right. So our goal is to try to get everything on the left over here, like the variables on the left. All right, number one, we don't have to distribute. So I'm going to move this by doing this right here. Okay, getting some static somehow. Now, from here, this becomes negative 2x plus 9 equals 1. Now it's a two-step equation. In the past, with these problems, you technically have 4 ways to start this. But there's a reason we want you to get the variables on the left-hand side. When I say we used to team teach this, and we still do. A lot of the Algebra 1 teachers, we collaborate a lot, but it's going to help out for something later. Divide by negative 2. X equals 4. Okay? Now, moving on. All right, we got to leave this side alone. 14 plus 7n. Now, we do have to distribute on this side. Okay? So 7 times 2, 14n, plus 7 times 4, 28. Again, we want to move the variables to the left. 14n minus 14n. 14 minus 7n, 28. Subtract 14. Subtract 14. Minus 7n is 14. 5 by negative 7. All right. So here, n would equal 2. All right. Now, I've only pulled in so many from the handouts because I want y'all to be able to see it. I know some people they always complain, we don't have enough room on our paper. Well, up until now, we've been having to print these out, and they're expensive. All right. Now, I did carry this thing along in case you need it. All right. This we have lots to do. All right. We are going to have to distribute first. So we're going to have 5g minus 5 plus 8 equals 2g plus 17 minus 1. Now, we need to combine like terms. Now, that's combining like terms on each side again. So right here's our like terms. So 5g just kind of hangs out. Negative 5 plus 8 is a positive 3. All right, over here, our constants are our like terms, so 2g, it just kind of chills. 17 minus 1, 16. All right, now we get to get our variables on one side. All right. I used to say like Red Rovers, and 2G on over. And that was in the good old days where, you had dodgeball and stuff and PE and recess, and, somebody would get clothesline the whole time. Loved that game. We used to play it when I taught at Liberty until we played it inside, and somebody did get clotheslined, almost hit their head on the floor, so I decided it's time to stop that. All right. Again, I'm just working through the steps. I got my variables on one side, I got my coefficients, constants on one side. Sorry, I was reminiscing about the good old days. All right. Divide by 3, divide by 3. Now, 13 is not divisible by 3, so we get this nice little improper fraction. Okay? So, these do take some time. All right, this is usually where people start getting frustrated because they think they're photomath and they're not. These do take some time. All right? Moving forward. All right, number 4, we don't have to distribute, but we do have to combine like terms. All right, remember, this is like a -1, so -1d minus 3d. This is -4d plus 12 equals 5d minus 6. All right, got to move done that. Got variables on one side, so minus 5d minus 5d. Minus 9d plus 12 equals, now, this is where people, again, they mess up. They forget to bring that -6. Happens all the time. Nope, go away. Okay. -9d equals -18. -9, 9. So d would equal 2. Now, if you think that this is bad that we did all that work for d equal 2, I remember there were some classes I had in high school. I would work these problems out. They would take the whole front side and the back side, and the last thing would be like 0. It's very, very frustrating. All right, we have to distribute 4m minus 8 equals 6m minus 6. Okay, again, if you have to mark them out, please do. All right, so I distributed that we have unlike terms. Add 6m. So 10m minus 8 equals -6. Ha! Still got a little negative clowning around with us. So I'm going to add 8. Add 8. I get 2. Now, when you divide by 10, all right, this is going to reduce down to 1 over 5. Okay? 2 over 10 as a fraction reduces down to 1 over 5. So we're going to leave it like that. All right? Now, this one right here, this usually confuses people because they don't see this. Remember, you treat this as a -1. Basically, if you see a negative out here, let me see if I can help you out here. If you see a negative out here, like this, whoop, come on, there we are. What that's going to do is when you distribute, it changes the signs. Okay. So -1 times 4 is a -4y. -1 times a -8 is a +8. Okay? Now, 2 over here, 2 times y is 2y. 2 times 4 is 8. All right, distributed, they're all unlike terms. Oh, let's do purple. Variables on one side. 6y plus 8 equals 8. All right. Constants on one side. There's 6y equals 0. Now remember, there's only one thing y could be. Anything times 0 is 0. So y equals 0. If you divide by that -6, that's fine, but most teenagers will not do that. I won't even do that. I'm far from a teenager. I'm 24 years past being a teenager. All right, a couple more problems. Lots of practice, lots of practice. All right. Now, with this one right here, I would treat this as a -2. Okay. Boop, boop, boop. And there's a reason why. You can multiply by a positive and then it's like a minus, but if you treat it like a -2, it'll be good right off the bat. -8y minus 10, 7a. All right, combine like terms. So we get -3a minus 10. Goodness. 7a. All right, now this is going to be the one exception where we're not going to get the variables on. Well, let's just go ahead and do that. Some people will know that you'll add 3 and everything, but I want to show this. Because if you do this, all right, people forget to do the equals 0 and then they can combine. But I know some of y'all would have added a 3 and get done. Either way is fine. By -10. 10. A equals -1. Okay. And some of these, these problems are looking a little bit bigger. They almost look like a catfish date. Okay. I say that because they're not what they appear to be. 11w, 2 times 3 is 6w, minus 2, 15w. All right. Now I'm combine like terms. This is going to be 17w minus 2 equals 15. Now I'm going to work this one where I move everything to the right, just to show that you can. But when we get to inequalities, you will understand why I've been trying to tell you to get everything on the left, because we'll probably have to clarify some things, some bad habits that people have. Ha, here's another problem, equals 1. Isn't that lovely? Looks like there's something else down here. Is there? Nope, nope. Oh, that's a whole lot of mess from the last time. All right. Wow. Hey, here's the deal, Pickles. If you're seeing problems like this on the notes, you're going to see problems like this on the test. Okay? And your test is coming up soon. All right. Don't have to do anything here. 4 plus 8 minus 5p is -15p minus 10. And then tag on the 5. Don't distribute this right here. It's not in parentheses. Okay? Now, I'm going to combine like terms. So this becomes 12 minus 5p, -15p minus 15. All right. I'm going to move everything over here because that would make sense. The reason why we moved it to other sides is because it was all the variables were over there, but half of one and 6 dozen, or half dozen of one, 6 of another, however that saying goes. 12 is 10p equals, here's another negative. It's 12, it's 12. 10p equals negative 27. So when we divide by 10, all right, p equals negative 27, 10. That won't reduce. Okay, that won't reduce. Let's make sure there's not another problem. Okay, there's not. That won't reduce, so we leave it like that. Okay. So improper fractions, unless otherwise. Now, if you're given decimals, answer can be in decimals, but if you're not given decimals, leave it as fractions or improper fractions. All right. Words. Okay. Basically, you can read that to yourself, but that won't make a lot of sense till we actually do it. Now, over here, we're going to distribute 12x minus 6, 12x minus 6. All right. At this point in time, I would actually tell you to stop because your answer is going to be IMS, or infinitely many solutions. Okay. If you were to keep on working, this is what's going to happen. Negative 6 equals negative 6. That's a true statement. If you were to add 6 to both sides, you're going to get 0 equals 0. Okay, so it doesn't matter what we plug in here for x, we're going to get the same thing on both sides. That's basically what this is saying. All right, something has infinitely many solutions if there's a true value. Okay, as long as it's a real number, and believe it or not, we will actually get into something called imaginary numbers. Yeah, that's going to be fun that day. All right, 2n plus 4n minus 8 equals 8 plus 6n. Now, if you are working ahead, you're going to probably get ahead of me. Oh, let's use another color. Let's use purple. Okay. 6n minus 8 equals 8 plus 6n. All right. This is not the same on both sides as it was over here. So please don't tell me this is IMS. All right. When you move the 6n, all right, you're going to end up with negative 8 equals 8. Okay. This is a false statement. That can't happen. All right. This is when your answer is going to be no solution. Okay. So true statement, IMS. False statement, no solution. Okay. Now, this is just another thing. IMS is when the equation is true, like, 2x minus 9 equals 2x minus 9, 3 equals 3, 0 equals 0. All right, that's a true statement. No solution is when the equation is false, like 0 equals 4 or negative 5 equals 100. You would not believe how many people will tell me that this right here is IMS. Okay. When we've had this before on tests, people will just write IMS or no solution, alternating all the way down and hoping they get it right. One time on the test, we had none of them. All right. So let's work some of these problems. Remember, this is distributing negative, so you could actually do the distributive part right here, or you could just change the signs. Negative 4, okay, minus 2. Nope, plus 2. That's not a true statement. That's an N right there, Jeffrey's mortgage variable. Positive times a negative times positive is negative. Negative times a negative is positive. All right. So when we were to add 4n to both sides, we end up getting -2 equals 2. That's similar to what we had a while ago. This is no solution. Okay. Now, I know the directions say if it has a solution, if it has no solution, write no solution. This is the same thing to me. Okay. It's the same. Plus, you're not writing anything anyways. All right. There goes the whole thing. So this is -2d plus 8 equals 2d plus 8. Are they the same? Look at the problem. If you have issues with this, after you do a step, I suggest you look at it for like 3 to 5 seconds. Okay, these are not the same. So I keep going. Minus 4d plus 8 plus 8. Minus 8 minus 8. -4d equals 0. All right. This is a solution. Okay, 0 can be a solution. Don't tell me if you get 0 that it's no solution. That's not happening, Captain. Okay, D can or 0 can be a solution. But for most people, it's a problem because you're not doing your work. Okay. Right, that's for okay. So this is good right here. These are our like terms right here. I'm not distributing. I'm saying that these are like terms. So this is -5. So this is -k minus 18. Aha, this is the same. You can stop. Not IMS. All right. So that's how you would actually solve equations of variables on both sides.